All right, well, hello physics students, and welcome to this video lecture. That's going to kind of formalize the process that I want us to take to solve projectile motion problems, specifically right now horizontally launched projectiles. So I have one problem that I'm going to go through. I'm going to show you all the steps that we need to take to solve these problems. So we have a car in a James Bond movie. It's flying off a cliff with a horizontal velocity of 22 meters per second. And that cliff is 45 meters high. So just to draw a little picture of the scenario, again, I always encourage you to draw pictures because I think it helps in just visualizing what's happening. That's a really weird looking car. All right. Anyway, we have this horizontal velocity, so that's going to be our v initial x, and that's 22 meters per second. And then our cliff is 45 meters high. Okay, now again, first thing that I would suggest you do is to always organize your stuff, all of our knowns and unknowns, in our t-chart here. Okay, so our x and our y directions. Now in the x direction, we know v initial in the x, and that's our 22 meters per second. We don't know delta x, that's what we're trying to find in part B, so that's a question mark, and we also do not know time, but that's what we're finding in part A. In the y direction, well, we know that there's no initial velocity in the y because this is a horizontally launched projectile. We know our delta y, and that's going to be negative 45 meters per second. Well, not meters per second, meters. Negative 45 meters. And just to remember why it's negative, remember we always take final, we always take y final minus y initial. Our y final is going to be 0, and then our initial is 45 meters, so then we get the negative 45 meters. Okay, we also know acceleration in the y, which is our negative 9.8 meters per second squared. And then finally, we don't know time. Okay, remember that time is what links our two directions together. So in part A, we're trying to find time. Now, we can't find time in the x direction because we only have one known and we have two unknowns. However, in our y direction, we know three things and we don't know one thing. So if we know three things and we know one thing, we can use one of our kinematic equations to then find that fourth thing. So in part A, we are going to be using delta y is equal to v initial times time plus 1/2 at squared. And again, we know that v initial in the y is 0, so this is just going to go away. So we're going to end up then getting delta y is equal to 1/2 at squared. Okay, so now we can rearrange this to solve for t. I'm going to do this algebraically, and you can do this on your own. I think it's a good exercise. But t is then going to equal the square root of 2 delta y divided by acceleration. And if we plug all that we know into our time equation here, we are going to get a value of t to be 3.03 seconds. Okay, so we could go up here and we can replace that. Oops. And we can replace that for time. So 3.03 seconds, 3.03 seconds. Okay, now for part B. Let's see here. Part B, we need to find that horizontal displacement. Okay, so now if we look in our x direction, or our horizontal direction, we now know two things. We know our velocity and we know time. So we can just use that simple velocity equation. So Vx is equal to delta x divided by t. We can rearrange that to solve for delta x. So that's just going to be Vx times time. And then if we plug in our known values, we are going to get, let's see, let me do this on the calculator here. We are going to get 66.67 meters So that is the horizontal distance traveled by that car. Now on the next slide, I'll be working on part C. All right, so finding the speed that the car hits the ground at. We need to be a little careful here because this is kind of a multi-step part. Okay, first off, we know that the horizontal velocity is constant in projectile motion. So whatever we start with here, this v initial x, well, that's what our v final x is going to be. So our v final x is 22 meters per second. But our v final in the y, we don't know that. Okay, so we need to figure out what that is. So for part C, we need to figure out what v final in the y is, and here we can use our kinematic equation that looks like this. Okay, again, we know that v initial in the y is 0. So to find v final y, it's just dependent on our acceleration in the y direction and our time. So we can plug in v final y is equal to negative 9.8 meters per second squared times that 3.03 seconds, and we are going to get a v final y that is equal to, let me plug this into my calculator here. Our v final in the y is going to be negative 29.69 meters per second squared. Now this negative is just telling us that that velocity vector is pointing downward. Okay, so what just at that second before that ball, or this car, I guess, before it hits the ground, okay, it's going to have that v final x, and it's also going to have this v final y. And what we need to then do is we need to figure out what this is right here. Okay, this resultant velocity, and I'm just going to call that v final. Okay, we need to figure out what v final is. Well, remember in class I kept asking you, okay, what kind of shape is this? Well, it's a right triangle. So all we have to do then, knowing this and knowing this, we just have to use Pythagorean theorem to figure out what this v final is. So doing that, we can say that v final squared is equal to vfx squared plus v final y squared. Okay, and then just doing some simple math here, I'm not going to do this all out, but if you do this, you should get an answer of 36.95 meters per second. Okay, so notice that part C in this problem is kind of a two-part problem. We already know that whatever our initial velocity in the x is, that's going to be what our final velocity in the x is. But we need to figure out what that v final y is because we have acceleration in the y direction. And then we can see here that that v final in the y is just dependent on what that acceleration is and the time that that object is in the air. So I hope that this video is helpful in formalizing this process that we take. And please, if you have any questions, write them down and we can go over them in class tomorrow. All right, thank you.